Anyway, we're going to go on and we're going to talk a little bit about how a modern diesel engine works, what the difference is between what we came from 20 years ago to today, and why this innovative technology from Steinbauer is so successful in the marketplace. The modern diesel engines, particularly those built in the last 10 years, have virtually all gone to what we term common rail. So from that sophisticated injection pump, or this sophisticated injection pump off an older Dodge from the early 90s, to even that injection pump off a 1500 horsepower tank engine, we've gone to this, what we term a dumb pump here. It's a simple 3-plunger pump that can make 30,000 pounds of pressure. That pressure comes out of this fitting and goes into a rail, and this is where the word common rail comes into. So the fuel pressure from the pump all comes into this rail of metal, and this rail of metal is pressurized all the time. So when an engine's under load, the computer commands there to be so much pressure in the system. And under load, we're running about 28 to 34,000 psi, depending on the model and manufacturer of the engine. That pressure sitting here all the time, and we have this modern, sophisticated injector. Now our old injectors, with the old system, you can see a simple little injector, these things sell for $40 or $50. These modern sophisticated injectors sell for upwards of $800. So the way the system works is the computer says, I want 28,000 pounds of pressure. This rail sensor, a very sophisticated sensor that converts pressure to voltage. And all modern engines now work on voltage. They can't see pressure. They can't see anything but electricity. The computer works with electricity. So this sensor sends a signal to the computer and says what the pressure is in here. And then the computer looks at what it wants it to have. We call that desired pressure and actual, and desired and actual. And it keeps that pressure where it wants to be. When the computer commands an injector to fire and put fuel into the system, into the combustion chamber, fuel is injected out the end of here into the combustion chamber. And the really nice thing about this, compared to the old systems, is that they can squirt this fuel in there anytime. The old system was tied to the camshaft and to the crankshaft, and it could only inject fuel however it was timed. Now with this thing, the computer can change the time that that fuel goes into the combustion chamber, and that's very, very important for emissions. All right, diesel engine 101. We're going to talk about voltage, and we're going to talk about time. So this is voltage and this is time. And we've got an ECM here that has all kinds of inputs from the various sensors, from your throttle pedal, air temperature, boost pressure, water temperature. There's all kinds of inputs into the modern ECM in an engine. Then you have your injector, and you've got a couple wires that connect to injector. This is the positive wire, what we call the current. The current that powers that injector varies from 12 volts all the way to 120 volts, depending on the system. And this is the ground. So the way the modern system works with these injectors is that the current, the juice, the power, however you want to term it, is always sitting there. And the computer, when it commands that injector to fire, completes the ground. So I'm going to just show you quickly how on an oscilloscope that looks. Computer commands this injector to fire, it sits along like this, and then all of a sudden the injector fires. And the voltage goes up momentarily because the coil moves, and then it settles back down and the injector turns on for a certain amount of time. So this injection signal right here, we're going to say that signal is 3.5 milliseconds, ms, milliseconds. So what do we do at Steinbauer? We just simply add on to that signal. Real simple. We add 20% more to that signal. It's really not that simple though. The key is that we have to grab that ground that the factory is going to open at precisely the right time. I can't stress enough how critical this is. I'm going to tell you why. Because we've got all this current in this engine, sometimes 120 volts, like I said. I use the term juice. There's a bunch of voltage or juice sitting there. If that wire gets rubbed through under a tappet cover or on the harness, it can rub through, and just like your booster cables, if you hook them up wrong on your battery, they spark and weld things and can do some damage. If one of these wires rubs through here, it can damage the ECM. It'll fry, what we call fry or burn out, the voltage driver or the current driver that shorts this to ground. And it can happen very, very fast. It happens in milliseconds to damage one of these ECMs. So in the system, there's what we call monitoring software. So there's some software that's looking for grounds all the time. And if it sees a ground, it sets a ground, what they call a ground fault. We'll get a fault code. An engine light will come on. Or on modern farm equipment and modern industrial equipment, right in the screen, it'll say a fault. So this fault can be caused by a ground. So it's always looking at the grounds and shorts in the system to protect the integrity of the system. But any of you that knows just basic electricity, when we take current to here and then we put this to ground, that's a short to ground. So what does the monitoring software do? Well, it looks, and because this happens so fast, it looks at this 0.5 or 0.3 millisecond voltage peak, and when it sees it drop down, it ignores that ground. Basically, it has to ignore the process of the injector firing so it doesn't set a code. So it goes along like that, and it ignores for 3.5 milliseconds, and then as soon as it sees the voltage start to drop, when the ECM opens that circuit, and now the coil in the injector is going to close, the monitoring software starts to look again. And this happens during each injection process. It looks for shorts and then it ignores shorts, and it looks for shorts and ignores shorts. And that's why it's so important when I talk about Steinbauer. It's really, really important on the install. Anyone that's involved in putting this product on an engine, it's important to have the ground, because we grab that ground. We grab Steinbauer when the ECM has got that ground. We grab that ground right at the time, within a few microseconds, not milliseconds, within just a few microseconds, we have to grab that ground, and we got to put it through the Steinbauer performance module and hold that ground on a little longer. If we wait a little bit and that injector starts to close, and now the voltage starts to drop, the software starts to look at that ground, and then when we grab the ground, it says we got a short to ground. It's really, really important that we install this product so that the ground wire coming from the Steinbauer module, and there's a power wire, and on the same harness, there's a ground wire. And that ground wire needs to be installed somewhere on the engine block, on the AC compressor, near the ECM, on a good ground that's not painted, doesn't have any corrosion. A lot of highway trucks get some salt corrosion, that stuff on there. Make sure that ground's installed properly. Again, that's simply what we do. We grab that signal, we add on to it, and that's what happens with Steinbauer.